Hello. So, in this video, we are going to be doing some algebra with functions. Yay! Not to be confused with algebra with functions, which is a whole other thing, believe it or not. Probably don't want to Google that because that's like weird graduate level math stuff. We get very weird in math land. Nonetheless, so I have two functions, right? F of x, g of x. And I want to put these together, but I'm putting them together in particular with this like 3f plus 2g minus fg all of x. Now, I want to sort of point out to keep in mind, this is not like 3f plus 2g minus fg times x, right? This is just like doing that f of x notation. So you could think of this, for example, if you wanted to, you could think of this as saying something like, and to be clear, this isn't necessary as part of the solution process, but I just want to be clear. If you have some h of x defined as, let's say, 3 times f of x plus 2 of g of x minus f of x, g of x. So that's basically what is happening here, right? Is I'm defining a new function. I've given it a name, but I didn't really need to. I'm just calling it f of x. And that function, f of x, right, this thing is this combination. It's 3 times f plus 2 times g minus f times g. So notice I'm not really like, this isn't me distributing x. This is f of x, g of x, g of x, f of x. It's that f of x notation, right? That's the idea. So I'm not multiplying by x. I'm just saying that function of x, that's what goes there, okay? So again, in particular, what I want to do is go through this, and everywhere there's an f, I want to replace it with f. So f, remember, is this thing up here, this x squared minus 3x plus 1. Then I also want to go through and replace everything that is g of x with g, where g is that square root of x minus 2 plus 1. Right, so I replaced that f, I replaced that, g, and then I have the product, so I'm going to have f, which again is x squared minus 3x plus 1 times g, which is square root of x minus 2 plus 1. And that's it, right? So I did 3 times f plus 2 times g minus, right? And always remember parentheses are key here, minus f times g, right? Multiplied the 2. And that's all there is to it. I could try to like expand all this out and, you know, combine like terms or like simplify or whatever. But again, the question doesn't ask me to do that, right? It just says, compute this thing. I've computed this thing. I'm good, right? If the problem asked me to simplify or something, then I should simplify. If the problem was like, which of the following, you know, is the result of that, then maybe I'd have to do some work to make it match an answer or something, right? Like there are cases where I have a reason to simplify, to expand this stuff out. But unless I have a reason, unless I'm like, I need to figure out which of these is the right answer, this doesn't look like it, let me try expanding, don't do that to yourself, right? Only do it if you need to, okay? Is that? Hello. So in this segment, we are doing algebra with functions. So I have some f of x, some g of x, and I want to compute this combination of the two, right? So again, to be clear, this notation, what this is saying is everywhere you see f, right, you replace it with the f of x expression. Everywhere you see g, you replace it with the g of x expression. This of x is not times x. It's just saying that you have a function in terms of x, right? So function, this whole bit, in terms of x, not times x, okay? So if I'm gonna, so let me maybe write this down and color coordinate a little. So I'm gonna have minus 2 times f, all right, plus 5 times g plus f times g. And it's that of x. Right, not times x, of x. Okay, so to this end, everywhere I see f, I'm going to plug in f. Everywhere I see g, I'm going to plug in g just as is. So I'm going to get minus 2 times, and then f, which is x minus 3, times x plus 1. Looks like my green might be starting to die on me a little. Sorry about that. Okay, plus 5 times g. So my g is this bit up here, 2 to the x minus 1 plus 3. And then plus f, which again is x minus 3. Might have to retire this marker here, times x plus 1. So that was f times g. Oh, sorry, I missed the 2 times that, so I should have a, I'm gonna do it in blue. I should have a 2 there, right, from that 2. So I should have had a 2 up here. Right, always good to reference the original as you're going to make sure that you don't have any errors. That's how you catch it without sort of getting all the way through. So g, which is 2 to the x minus 1 plus 3. Okay. And that's all I have to do, right? I'm, again, to be clear, I'm not multiplying by x, it's of x. And I could expand this stuff out, but there's no need to unless I have some actual compelling reason. But here it just wants me to compute. I don't have to compare it against answers. I don't have to compute with it. Like if it was like, now compute, you know, this thing at 27. Maybe it'd be worth taking a moment to like simplify some stuff beforehand just to make the computation easier. But I don't have to do any of that because it doesn't ask me. So there's my answer. Okay. So that's that. Hello. So in this segment, right, we are going to be doing some algebra with functions, right? So I have an f, I have a g, and I want to combine them in some way and make a function of x, right? Not times x, of x. So do this. I'm gonna write the first line. You don't necessarily have to write this part, but I'm gonna do it so that you can sort of see the coloring. So I'm gonna do f minus, and I have 5/2 g minus 2f over g. Right, and the idea is I'm applying all of this to x. Again, not times x, not doing multiplication by x. This x is saying that these are all functions, and that's how I'm putting them together. Okay. So for f, I have f up here, so I'm just going to plug this in where I see f. So I have, let's see, natural log of x minus 3 plus 7x. Then I'm going to have minus 5/2 g. Well, I know what g is, right? G is this thing, this x squared minus 3x plus e to the x. And then, right, I'm going to subtract off 2f over g. So I'm going to have minus 2 times f, which again is natural log x minus 3 plus 7x. Yeah. Right. Parentheses always a good idea, especially, for example, here where I'm going to need to, right, distribute that negative if I were to be simplifying any of this, which, spoiler alert, I'm not. And I'm dividing by g, which is this x squared minus 3x plus e to the x. Okay. And that really is it. I don't have to do anything else, right? So again, if I had a reason, I needed to compare against answers, I needed to do some nasty computation, or it just explicitly told me to simplify, then I might expand out and simplify and do like a common denominator or whatever. But it doesn't tell me to do any of that, right? Like I don't have any of those situations, so I'm not going to do it. I have the answer. That's it, right? That's all I need. Okay. So that is that.